Assalamu alaikum. My name is Aisha Batul and my roll number is 16TE01. Today our lecture is lecture number 11 of digital signal processing. As we know that in the previous lecture we have studied about the discrete Fourier transform. Today we will do some more examples about the discrete Fourier transform, and we will have a concept of inverse Fourier, discrete Fourier transform. Let us have a sample x of n is equals to 1, minus 2, 3, 1, 2, minus 1, 2, 1. Now we will see the formula as we have calculated the formula x of n is equals to 0 to n minus 1, x of n, here it is k, e raised to power minus j 2 pi n k by n. This is the formula for discrete Fourier transform. Now we will put the values accordingly and we will have the final results. As we know that there are 8 samples, so n minus 1 will be 7. X of 0, e raised to power minus j 2 pi 0, and accordingly I have the value for x of 0. Now x of 1, x of 2, x of 3, x of 4, x of 5, okay. After calculating likewise, I will have the following results. And x of 2, x of 3, x of 4 will be 9. And then after x of 4, I will have the conjugate values of x of 5 will have conjugate value similar to x of 3, that is minus 0.2929 minus j 1.707, and x of 6 will have conjugate value of x of 2, that is minus 2 minus j 5, and x of 7 will have a conjugate value of x of 1, minus 707 minus j 1.707. Okay, now let us see these values in the frequency domain. X of 0. I will take the magnitude of these values, that is the real part and the imaginary parts, and then square root. As x of 0 is having only the real part, so I will take only the real part. It will be 7. Likewise, I will calculate the magnitude of the rest of the following, that is 1.73, 5.38, 1.73, and x of 4 is going to be 9. X of 5 is going to be 1.73, again the same value as x of 3, and x of 6 will have the same value as x of 2, x of 7 will have the same value as x of 1. Okay, now we will calculate del f, that is the frequency resolution, is equal to f of s over n. Here f of s is the sampling frequency. If we are not provided with a sampling frequency, we cannot plot the frequency plot. It's the number of samples that are 8 in this given example. Okay, let us consider that f of s is 16,000 hertz. Okay, inserting the values, I will have 8,000 hertz del of f. Now we will plot the frequency plot as taking 8,000 as the maximum frequency. Okay, 2000 difference, 4000, 6000, 8000, 10k, 12k, and up to 14k. Okay, we will plot the magnitudes. As we know that at x equals to 0, I've got 7. So here 0, got a 7. At x of 1, it is basically the difference is 2000, and after this it will repeat the interval. It will be for 4000 difference, it will be of 6000 and onwards. Okay, it will be 1.73. At 4000 I have the value 5.38, and at 6000 it is 1.73 again, and x4 it is maximum, that is 9, and 10k it is 1.70, repeating its value, and it will be the same 5.38, it will be 1.73 again. Okay, now what we are doing, it's the maximum f max, it lies at 8k, and basically it is equal to pi in the normalized form. Okay, now if we want to filter the frequencies above 7 kHz, that is above this spike, what we are going to do, we will let x of 4 equal to 0, and we will go into the inverse Fourier transform. Formula for inverse Fourier transform is x of n is equals to 1 over n is equal, k is equals to 0 to n minus 1, x of k, and e raised from j 2 pi k n over capital N. Okay, we will find the values accordingly as x of 0, x of 1, x of 2, x of 3, x of 4, x of 5, x of 6, x of 7, as we have calculated before, but here we will consider first k is equals to 0, and then we will find values. Okay, we get the following results, that is minus 0.125, 0.875, 1.8730, 2.1250, 0.8750, 0.125, 0.875, and 2.125. Okay, now what we will do is we will plot the original plot of x of n and the after x of 4 equals to 0 plot. Okay, and then I will have the conclusion. Okay, let me plot the before and after results here. X of n before 0, 1, 2, 3, 4, 5, 6, 7. That's the time domain. It's the amplitude. It's 1, and that 1 is equals to minus 2. 2 is equals to 3. It is again 1. It's equals to 4. It's equals to 2. It is minus 1, and again 2 and 1. Okay, if I sketch this graph, it will have this type of shape. Okay, now I will plot the after x of 4 equals to 0 plot of x of n values. Okay, 0, 1, 2, 3, 4, 5, 6, and 7. The amplitude, okay. But we get the four values. Okay, will be minus 0.125, something like this, minus 0.8, then 2.125, 1.8737. Okay, and x of 0, it is 0.8 something here, and x of 5, it will be minus 0.125, and it will be 0.8 and 5 and 2.125. Okay, if I sketch this graph, it will be like this. Now, by looking at this graph, what we get the results are if the frequencies are higher, as in the original x of n graph, the transitions are higher. And if the frequencies are lower, we get less transitions. Hope this video will be a bit helpful for you. Thank you guys.